Okay, so again, we're talking about slopes of parallel and perpendicular lines. So section 2-4, page 92, this is the last section in this entire unit. So we're supposed to have our test on Thursday, all right? So again, after today, tomorrow and Wednesday, we're just reviewing over things. Now, parallel and perpendicular. We talked about these briefly when we did our very first set of notes. So we're doing this in terms of a coordinate plane. So I'm going to draw two coordinate planes here. Here's a coordinate plane. So this is my x and my y axis. Here's a coordinate plane. X and y axis. And on the first one, I'm going to roughly draw a line that has a slope of about a 1/2 slope. So, again, it doesn't have to be perfect. I'm going to say the slope of this line is 1/2. And then I'm going to draw a line that appears to be parallel to it. What should be true about that second line's slope? The line is parallel. The slope is... Okay, so it's going to be a half because they are parallel. They're equal, right? Parallel lines have equal slopes. So the first one was a half, and these are parallel. Then that one should be a half because they have equal slopes. So parallel lines equal slopes. Now, there is one exception to this. All right, so let me read you the theorem straight out of our textbook. So again, hopefully you already have all these theorems done because they're on your vocab. Let me find the right one here. All right, so this was theorem 2-13. Two non-vertical lines are parallel if and only if their slopes are equal, period. But then there's a second line. Any two vertical lines are parallel. So we have to have either equal slopes or vertical lines. Why does vertical lines fall completely separate from the other? So either two slopes that are equal will make parallel lines, or two vertical lines. Why? Why don't we group this one with the other? What's the slope of a vertical line? Going back to algebra. No, it's not 0.
Right. What did he say? What's the slope?
What's the slope of a vertical line?
They didn't know. I mean,
No, this is algebra, guys. Come on.
it was a long time ago. Hey. Wait.
So you either have two lines with equal slopes, or you have two vertical lines to make parallel lines. Why is vertical line separate? What's the slope of a vertical line? It doesn't have a slope. All right? It's undefined. Slopes are undefined for vertical lines. So can we set them equal? No, because they're undefined. You can't set two undefined values equal to each other. So again, you're either saying that you have equal slopes. Now, you could always define this as either case here. Same slope. All right, so either have equal slopes for non-vertical lines. So again, this is non-vertical. Or we have two vertical lines because their slopes undefined. I'm just going to add that on there since we had a little trouble there. All right. Now, when we talk about perpendicular lines, all right, let's draw a slope here of what looks like negative maybe 3/2, roughly.
I don't understand.
All right. So now, if I was to draw a line perpendicular to this,
You are blind. No. 3/2.
all right, 3/2. You sure?
Oh no, I wasn't. No. That's That's not what it's like.
She said 3 over 2. You guys want to agree with that?
Jackie's just blind. I'm not blind. She asked me what it said.
Oh, you asked what that said.
Yes.
Oh, so you just left out the negative of the original.
No, she asked me what the board said.
Oh, okay. So this one was negative 3 over 2. All right.
No, yeah.
So now, what would this one be if it's perpendicular? 2 over 3. So, how do perpendicular lines relate to one another? Opposites, just opposites? You said they flipped. What do you mean by flip? Reciprocal. I heard that key R word there. So, slopes are opposite reciprocals. Huh?
How do your lines come up so straight? And I have lines.
It's how you draw a line. Is draw a straight line. I don't know what you mean.
I don't know what you mean.
I mean,
They're not wiggly. What?
they're not wiggly.
No.
I don't know. They're straight. They're lines. I've been drawing lines for many years. All right. So slopes are opposite reciprocals. Now, opposite reciprocal. How do you define opposite reciprocal? Give you a hint. It's something to do with a product. They have a product of. No. When you multiply two numbers that are opposite reciprocals, they give you a product of. I don't think I've heard it from anybody. 1, you're close. -1. Now, do you guys remember talking about this? Maybe like, not last Friday, because I wasn't here last Friday, but 2 Fridays ago when we did these notes. And we actually wrote same slope and opposite reciprocal slopes, and I wrote some numbers on the board. No, that just completely fell away, and you guys forgot all about it already. That's scary.
That's scary.
All right. That wasn't even 2 weeks ago. That was like a week and a few days. All right. Moving on. So, now, just like there was one scenario, guys, just like there was one scenario that was different on the other one, so we had equal slopes or we're dealing with 2 vertical lines. We are going to have opposite reciprocal slopes except for when we're dealing with vertical lines because, again, we have an undefined slope. So for any vertical line, what would be perpendicular to it? What would be perpendicular to a vertical line, guys? Ladies? A horizontal line. Woo! Vertical lines and horizontal lines are perpendicular. So, you guys are scaring me today. I know it's Monday. So again, vertical lines and horizontal lines, those have to be perpendicular. One has a slope of 0, the other is undefined. Now, if you're given the one with 0 first, would you get the fact that the other one's undefined by trying to find the opposite reciprocal? Yeah, right? Because if you have 0 as your slope, what happens if you go and flip 0 so that 0 goes on the bottom? Anytime you put 0 on the bottom of a fraction, it's undefined. Right? Alright. You guys took algebra before taking this class, right? Okay. You got a 5 on the OC. Alright. So you remember this stuff, right? Not at all. You never talked about horizontal and vertical lines and parallel and perpendicular and. All right, move. Let's keep going. I don't want to. Sometimes. Okay, let's try the next part. Maybe this part is going to be more familiar to you guys. Slope. So, first, what letter represents slope? I've already written it 4 times on here. All right.
No.
M. All right, let me move this up. So M represents slope, right? Now, there are at least 3 good ways you could kind of define slope. Actually, there's more than that. There's at least 4, I'd say. How do you find slope? Because we need to talk about in terms of giving points, finding it, or giving an equation, finding it. What? So that's slope-intercept form, which we're going to talk about in just a few minutes. So we are going to talk about equations in just a minute.
Is it M plus B? No. No. There's a B.
So that you guys are thinking slope-intercept form. She just said slope-intercept form a second ago.
Oh, wait, what are we?
So slope. How do we define slope? All right.
Is it M?
Let's start with this. Shh, guys, let's start here. Let's start easy. If I say rise over, you guys remember slope in that manner, right?
Yeah.
So like if you're looking at a graph, you go up and then you go over. How did it change? Or instead of using the basic terms of rise over run, you could say change in y over change in x.
Then which was the X?
Or, better yet, the equation. How do you find change or difference? What operation do you use? Subtract. So we're going to do y2 minus y1 over x2 minus x1. All right. So, is it starting to look familiar? No. Okay, well, I don't know what happened last year in algebra then.
Why don't we take algebra 1 and algebra 2 back to back? Wouldn't that make more sense?
Because you have some geometry in algebra 2. Like the trig section that we're going to do, you do more trig in algebra 2.
Oh, we can't say geometry. Might have to use graph paper now. Who did it?
I mean, if you want to use graph paper, if you have graph paper, sure. I'm just drawing a simple figure, though. Again, doesn't have to be a complicated graph here. I'm only drawing this one graph with all these marks on it today. So now we're going to plot a couple points. So this is for an example. All right, this is my example for slope. All right, we have a graph. I'm going to give you 2 points. The point -2, 3. -2, 3, and the point 2, -3. So we're starting easy here, hopefully. Hopefully you guys think this one's easy.
Hopefully.
2, -3. And then we're going to draw a line. And if you draw this line accurately, I will tell you, it actually intersects the origin. Let me make those dots a little bit bigger. All right. So now, whenever we do this, whenever we find slope, again, we could use the points, or we could use the graph. So, looking at the graph now, you actually can tell, hey, it actually goes through 0, 0. So if you wanted to use 0, 0 as a point, that works too. All right. Now, I do have these 2 labeled, so I'm going to go ahead and use those 2 for right now. But I'm going to go ahead and label what the change is. First, the vertical change, so going down. And then the horizontal change going over. How many units did we go down? Down how many? 4. 24. Wait. Shh. Okay, hold on. So from 3 down to -3 is how many units? 6. And we're going down, so it's a negative direction. Now we go over. How many units do we go over? 4. Again, if we're looking at a graph, we can count these spaces, not the lines themselves, but the spaces. So we went down 6 units, over 4 units. That's one way you could have done this. So M equals, again, rise over run, change in Y over change in X, which is now negative. We could reduce that. 3 halves. Now, does it matter if you put the negative on top or on front? So could I do this? Yeah, these are equal. Those are equivalent. There's only one negative sign there, right? One of the most common mistakes with a negative slope when people go to graph a line is they'll look at this and be like, hey, the negative's out front, I gotta go -3 and -2, so then they go to the left.
That's me.
That's not correct. There's only one negative. So you either put that negative on top or put the negative on bottom. Do not do both, because 2 negatives make a positive, and this is a negative slope. All right. Now, that's the visual way, right? Looked at a graph, we picked those numbers out. You could have also used this, because we were given the points, right? So if we had plugged in, let's say I use this as my second point, I have -3, +2, minus +3 and -2. So, oops, let me move it up. So again, I just plug this point in, I plug this point in, and now -3 minus 3 is -6. Minus a negative is adding a positive, so that becomes 2 plus 2, which is 4. And again, we get the same answer. So again, you can look at the graph. You can do the equation. Either one works.
So like this is 2 minus -2, just like turn it into a positive?
Yep, plus a positive. Minus a negative is plus positive. All right, so now there are 2 formulas that we should know. 2 different equations for a linear graph that we should know. One of them is called slope intercept form. The other one is called point slope form. The name pretty much tells you what you are given in each equation. Slope intercept, you have the slope and an intercept. In fact, it's the y-intercept. Point slope, you have a point and a slope. Now, our equation here, y equals, and one of you ladies over there said it earlier, you ladies were also trying to think of this one. mx plus b, there we go. Y equals mx plus b. Now, point slope form. Alright. It's essentially based off the idea of our equation for slope. Right? So let me rewrite this up here just with that last part. Again, you don't have to rewrite this. I'm just rewriting it for a second. Essentially, if you were to take this out of the bottom and move it over with m, that would end up being our equation. Now, it gets flipped around a little bit, but it's the same thing. So it's y minus y1 equals m times x minus x1. Now, I didn't put an x2 and a y2 because when we do this format, you got to remember, one of these x's and y's represent all the other points that are on that graph. So we don't plug into that one. Same way with our slope-intercept form. We don't plug in for x and y. We only plug in the slope and the y-intercept. Here we plug in a point and our slope. All right. So again, those 2 formats look familiar, right?
Yeah.
Okay, hope so. So now, this is the basics that you have to know in order to do any of the problems in this section. All right. So now we're going to take a look at some of the problems. All right.
It is way easier
geometry. Oh.